Okay guys, welcome to chapter 11. Notice we skipped lessons 1 through 6. We're jumping straight to lesson 7, which is discussion of powers of binomials. Now, you need to remember what a binomial is, and it's something that looks like this. That's a binomial. Two terms, and we're going to take them to power. Do you remember how to square a binomial? You should have a squared plus 2ab plus b squared. Okay, a little review. Now, this lesson is all about noticing a pattern when you take a binomial, like a plus b, and you raise it to different powers. Now, notice I'm including 0 and 1, which are unusual. That's because I want you to see the numbers to develop the pattern. When we normally write a plus b, we just leave it like that. We don't ever put the 0, because that would equal 1. A plus b to the first is a plus b. A plus b to the 0 power is 1. Okay, so you'll see what I mean here. Okay, I'm going to go ahead and write these down, and you're going to notice a pattern, I hope. A plus b to the 0 power is 1. A plus b to the first power is a plus b. And I'm going to go ahead and write some exponents here and coefficients, because I want you to notice this. Okay, a plus b squared is 1a squared plus 2ab plus b squared, 1b squared. Okay, now 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay, there's a pattern developing here. Now, notice I actually didn't work all these out right now, so I'm putting these down faster than what you would be able to do when you work these out. These are already done beforehand. I just want you to notice the patterning. So 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a squared b cubed plus 1b to the 4th. Last one for now. 1a to the 5th plus 5a to the 4th b plus 10a cubed b cubed plus 5a squared b to the 4th plus 1b to the 5th. Okay, so now let's see if we can understand the patterning here. There's two things to notice about the pattern. First, this forms a triangle. And there's a couple things to notice about the triangle. This is row 0 because the power is 0. This is row 1, row 2, row 3, row 4, row 5. So we did 6 rows. 2, 3, 4, 5. We did 6 rows, and then we stopped. Row 0, 1, 2, 3, 4, 5. We call this a 0, so don't get confused about that in order to match the exponent. Okay, now I'm going to draw the triangle, but without all the A's and B's, and I want you to notice. 1, 1, 1. Now, 1 is always on the edge, and then we add these two, and then it's 1. Now we're going to add 1, and then 1 plus 2 is 3. 2 plus 1 is 3. Back to 1. There's symmetry here. Okay, 1, 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 again. 1, 5, 10, 10, 5, 1. All right, now this was row 0, or 1, 2, 3, 4, 5. What would row 6 be? See if you understand this enough yet. 1, 6, 15, 20, 15, 6, 1. These rows are the coefficients of the variables, or of each term, in order. It's amazing how this thing works. Watch. If I say, write out a plus b to the 6th power, then you look right here and you go to that row, and you immediately know what the coefficients are going to be. You know it's going to be 1 something, 6, 15, 20, 15, 6, and 1. You know it's going to be that. Then let's go back up here and look at the A-B patterns. So notice, A If it's to the first power, then we start with a to the first power. If it's second, we do a to the second. Third, a to the third. Fourth, and so on. Then, okay, go back up here. Notice that the a drops by 1 each time until it disappears. 3, 2, 1, 0. 4, 3, 2. Whoops, that should be a 1, 0. 5, 4, 3, 2. Whoops. What am I doing here? Okay, anyway, you see how it works. Okay, so right here we should see that it starts with a to the 6th, and then a to the 5th, a to the 4th, a to the 3rd, a squared, a, and then it's gone. Now the b's are backwards. So notice there's no b, then a b. No b, 1b, 2b. No b, b to the first, b to the second, b to the third. No b, b to the first, b to the second, b to the third, b to the fourth. No b, b to the first, b to the second, b to the third, b to the fourth. Oh, sorry, guys, that's really bad. Okay, so here we go, back down here. B, b squared, b cubed, b to the fourth, b to the fifth, and b to the sixth. And then it's all pluses in between. You can write it nicer than that, but you get the idea. All b, and then that's how you can quickly use this pattern and the AB pattern to multiply a series of binomials like that really quickly. Okay. Now suppose now these things can get huge, so sometimes they'll abbreviate the problem and they'll say find the first 4 terms. So not all of them, just 4 of them, of something like this. Now to the 7th. So the first thing we got to do is find the 7th, or row 7 of Pascal's triangle. This triangle is called Pascal's triangle. The guy was a genius. He did so much amazing math. So we're going to come over here. Here was the row 6 that we came up with. Notice the symmetry. This is row 6. Now row 7, we're going to start with 1 and we add. So you got to be good at adding. Okay, so there's row 7. So we want the first 4 terms. So we're going to do the 1. I'm going to make better spacing this time. 3, 35, the first terms. Now, since we're dealing with an x and a 2y, what I'm going to do is pretend this is an a and that this is a b. So a is equal to x and b is equal to 2y. And so I'm just going to do a to the 7th, right? A to the 6th, a to the 5th, a to the 4th. You just go start at the top and go down. Then I'm going to do no b, b, b squared, b cubed. Okay, now these are all pluses. Plus, 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 plus. Okay, so now I've got the first 4 terms, except I've got to do it in terms of x and then negative 2y. So all I'm going to do is plug in x to the 7th plus 7x to the 6th, and then b is negative 2y, plus 23x to the 5th, and then b squared, so it's going to be negative 2y squared plus 35x to the 4th, and then negative 2y cubed. And then I got to take care of all this negative 2y stuff. So x to the 7th, first term, check. Then this is going to be minus 14x to the 6th y. Okay, now this one will be 2 times 2 is 4. 4 times 23 is 4 times 23 is 92. Right? Oh, guys, this should be a 21. I knew I was doing something wrong. Okay, so 21, 4 times 21, that's an 84. X to the 5th y squared, and then 35 times 8 is 280. 280 x to the 4th y cubed. And then there's more. There's going to be more. This is only the first 4 terms, but there are the first 4 terms. We did it. Okay, there's one more situation, because if you remember from the triangle, there's always symmetry. 1, 5, 10. 10, 5, 1. 1, 6, 15. Middle. 15, 6, 1. 1, 4, 4, 1. So watch this. Watch this. If you have something enormous, like a plus b to the 20th power, if I give you the first three terms, instead of figuring out all the rows of the triangle, you can figure out the last three terms. So could you tell me, the problem asks, if this is the first three terms for this expanded binomial, what would the last three terms be? We're going to use the symmetry. 1, 2, 3. The last ones will be 3, 2, 1. Okay, so now you know that this one's going to have no a's, this one will have 1a, and this one will have a squared. And this one will have b to the 20th, because it's got to be the 20th. This one will have b to the 19th, and this one will have b to the 18th. Done, and it's plus plus. And you can erase the 1 when you're done. Okay, guys, go ahead and start your work and let me know if you have any questions.